We here demonstrate our framework, DySE, short for Dynamic System Explanation, and in particular several tools: model simulation, interaction filtering, interaction classification, model extension, model checking, and sensitivity analysis. Here is an illustration of all components of DySE framework. We will demonstrate the functionality of those tools one by one with an easy graphical user interface or web-based interactive notebook.
In this demo, we will demonstrate integration of different tools in our DySE framework with a very easy-to-use graphic user interface. And in this video, we will use a T-cell model as an example to show the functionality of our tools. So for now, you can see the whole user interface, which is also the GUI. And you can see there are several widgets with the sidebar on the left that let users to choose which tool they want to use in this GUI. Let's start with opening our model in the GUI. So basically, we can open one model or model folder. The model will be displayed in the spreadsheet format by clicking the File button in the Explorer. As you can see in the display model, each element has its regulators and other related information. And our model follows the bio-recipe format. The logic function with elements are defined with different notations in this format. The model will be checked with our predefined color names. So according to this check, the model will be classified in different levels for being compatible with other tools. And users can choose which model display options they want to see. The first column of element name is frozen, which allows you to scroll to the right, left to see, and you can easily edit the model in the GUI. We also provide a const on and off functionality for users to shut down an element or to activate one element. And these two columns are designed for maybe gene mutation or adding inhibitors. And we can do the simulation later to see the influence. The model can also be visualized as a graph, with green color arrows representing positive regulation and red color representing negative one. The graph is interactive, which means you can drag the nodes and rescale the graph. The relations between regulated elements and regulators are also synchronized in the GUI. Which is easy for a user to have clear insight of the model. Now if the model has initial values, you can use our simulator to simulate. We provide an editor for users to choose the simulation parameters, such as steps, runs, and simulation scheme. You can also choose multiple scenarios to simulate. Now in our examples, we are using the random scheme and set the steps to 500 and runs to 200. Yeah, we also want to simulate both scenarios. The simulation will take some time. The steps and runs are very big. And the results will be stored in trace text files. The viewer will show up to display the simulation results. Because we have two scenarios, we can visualize one element in these scenarios, or we can just visualize the results of one scenario. So let me choose two scenarios, and for the AKT elements, so for this plot, we can see AKT is increasing in scenario 1 while remain at 0 level in the other scenario. We can also analyze the results in just one scenario. If we are interested in the first 4 elements, we can plot the trajectories of these elements. And the heat map and each run can also be plotted if you want. The viewer is quite flexible. It allows you to store the simulation results in your computer, and we can import and visualize it later. So I'm going to show the simulation results of another GVM model built in our group. The GUI is very flexible and user-friendly, and users can resize and move the widgets. Dynamic tab in the GUI allows users to import different types of files, and when we need to compare different models or even reading output, we can open them together to see the difference.